Right, hello everyone, welcome to this video. In this video I'm going to talk you through the rest of the simultaneous equations notes, and that way if you miss any of the live lessons this week, I will direct you to the part of this video which will be on YouTube for you to catch up. So I'm not going to do individual videos for each lesson, I'm just going to put everything on here and you can catch up with the bits you need to using the Teams page to let you know what bits to do for each lesson if you were to miss it. So continuing on from what Mrs McInnes did with you on Tuesday, I am going to start with this question here. So it's the part of the notes that is talking about solving simultaneous equations by substitution. Now, the stuff you did yesterday, it's very unlikely that you will use this. So if we look up here, you're not going to have squared paper in an assessment. It's very unlikely that you ever have to draw a straight line graph, especially one on squared paper where you have everything marked on. You may be asked to sketch one at some point, but generally not draw one. What's more likely to happen with a graphical method question is that you'll be given the graphs of two equations and you'll have to decide where they cross over, but you will do this using one of the two methods that I show you in this video anyway. So the first one of these methods is solving by substitution. Now that means taking an expression, so in this case we're taking negative x plus 5 and substituting it in place of something else within the expression, okay? So again, there's a little blurb at the top, there always is with these. So we're asked to do these algebraically. The first method is through substitution. It's a powerful method, but sometimes it can be quite complex if our equations aren't set up in the correct way. And I'll show you when that happens a little bit later on. So in this case here, you've got one full worked through example just to help you on. We have said that, so the first step up here, we should really say that y equals y. Okay, that's the same we did with what did we do it with? The functions topic before, when we said f of x equals f of x. So this is one version of y, this is the other version of y, so that's them two there. Put them equal to one another and solve the equation. Okay, so this is basically a little bit of a introduction into solving equations as well as simultaneous equations. Okay, the two examples on these are example 3, so I'm going to talk you through these quickly, and obviously there are questions to be done with them, but there are also a couple of extra examples included in these slides that you can work through. Okay, so the first step here for example 3 is to set y equal to y. This is one version of y, this is the other version of y, so 2x equals x plus 2. Take away x from both sides, 2x take away x is x, that disappears over there, x equals 2. Once we have x equals 2, we sub x equals 2 into one of our equations, so I'll always label mine 1 and 2, and I think I'll substitute it into equation 2. And equation 2 was y equals x plus 2, so if x is then 2, y is 2 plus 2, which equals 4. So in this case, x is 2 and y is 4. For b, we are going to make that 3x plus 3 equals 2x plus 4, so that we have y equals y. Take away 2x from both sides, that's x plus 3 equals 4. Take away 3 from both sides, so x equals 1. You can see solving equations is very, very important here. X is 1, sub that into one of the equations. Doesn't matter which one you use, so just label them 1 and 2, and I'll substitute into equation 1 this time. Equation 1 was 3x plus 3, so 3 times 1 plus 3, 3 plus 3 is 6. So x equals 1 and y equals 6 is the solution to that one. Now that tells me if I was to graph these two lines, they would cross over at the point 1, 6 in this case. So 1, 6 is where they would cross over here. For this one, it would be 2, 4. Okay. Also, if we're not talking about graphs, what we can say is that if I put the numbers 6 in place of y and 1 in place of x, it will create the same on both sides. If I put 6 here and 1 here, it will create the same number on both sides. We're looking for two numbers that when we replace the x and the y with them in both equations, we get the same number on both sides. So that's taken us away from the graphical method a little bit. Now we have a couple of extra examples. This first one here is telling us that y is equal to 2x minus 4 and x plus y equals 2. Now in this case, this is not in the form y equals something. We could rearrange it to make it in that form, but sometimes that's not always the best way to do these. So what I am going to do is, for the first step, substitute y equals 2x minus 4, so equation 1, into equation 2. So y is 2x minus 4. Well, here is that y. That then tells me that x plus 2x minus 4 equals 2. Because all I've done here is take this thing and replace it into the y. Okay, so I've substituted that whole expression in place of the y in the second equation. That leaves me with 3x minus 4 equals 2. And we can solve this to get x, so 3x is 6, x is 2. Now, second part for all of these questions, no matter which way we do it, is to substitute x equals 2 into one of the equations. Now I'm going to choose equation 2 since it looked a little bit easier. So I've got x plus y equals 2. So that means that 2 plus y equals 2, so y equals 0. And that there is my final answer for that question. So slightly different than before, and we're going to see another one that is slightly different as well. Okay, all of these are substitution. Now, in this case, I have got a y equals, and if you look here, I've now got a y in there. So this is equation 1, this is equation 2. I'm going to take equation 1 and substitute it into equation 2. You can see with these ones, it would be quite difficult to get equation 2 in the form y equals something, because then we would end up with a fraction in front of the x, which is something we want to try and avoid because it causes us more issues. It causes us to have to do more work. When I substitute equation 1 into equation 2, I get 3x minus 2 times equation 1, which is x minus 7. This here is y, which is also this here. That then equals 24, and this becomes a solving equations with brackets question. So 3x minus 2x plus 14 equals 24. Plus 14, since we have two negatives times them together. 3x take away 2x is x, plus 14 equals 24, so x has to be 10. Once we have what x is equal to, we can substitute that in to find out what y is equal to. So let's substitute into equation 1. So sub x equals 10 into equation 1. Now equation 1 was y equals x minus 7. So y equals 10 minus 7. So y equals 3. And that's our two final answers there. X is 10 and y is 3. Now again, that tells us that, to put it in context, if we replace both the x's and y's in both of these equations by 10 and 3, we will have the same numbers both sides once we do the calculations. So for this one, 3 times 10 minus 2 times 3, that should equal 24. Okay, so put the x and the y into the equation, we get the same number on both sides. Now, the next thing you would have to do, which we are not going to do during the lesson, well, we will see, we might, okay? But these questions at the bottom of page 8 are all based on the substitution method, okay? So we'll pay lip service to them. We will do a couple of them for a few minutes during the lesson, but we won't spend too much time on them, as the next part of the video is the most important part that you will do in simultaneous equations. So moving on. This method here, by elimination, is the one that is used most often. It is the one that is used when you have a context question, so you're given a story and you have to make up equations and so on. It is the one that is most able to be used with most of your simultaneous equations questions. It's the most popular as well, which it says in these notes. So the first thing we have to do, it gets us to line up both equations so that similar variables are above and below each other. So with these two equations here, we put them on top of one another and we try and make it so that we have generally x's and y's on the left hand side. So we rearrange both of those to make it y minus x equals negative 3, and for this one y plus x equals 5. Now when we do this, we can then add these two equations together. Once they're in this form, we can add them together, and we do this by adding them the same as you would an addition sum. Okay, so if I had to do, for instance, 24 add 31, you would add them in columns. We do the same here. We add those two together, which gives us 2i. These two together, this is why it's called the elimination method, negative x plus x gets rid of x, that's 0. So negative x plus x is equal to 0. So this is essentially plus 0 in here. But we don't need that, because plus 0 doesn't have any effect on our answer. We do the same with the two numbers. Negative 3 add 5 gives us 2. Well, if 2y equals 2, then y has to be 1. And after here, this step here is the exact same as what we did before. We get x equals 4 and y equals 1. Now these ones might seem relatively straightforward, and for the first few examples that we do, you will not have to do any sort of rearranging or multiplying, but that will come later. So, example 4. As we can see here, we have got two equations that are already set up for us. Sometimes they will appear in a past paper like this as well, which is always very useful. Sometimes they won't, however, and you'll have to create it and know to start them off like this. What we have here is equation 1, so we'll label them equation 1 and equation 2. And we're going to start to solve them. Now, since they're already in this form, I am going to add them together. The reason I'm adding them is because plus y plus negative y. So in this case, I've got y plus negative y becomes y take away y, which is 0. So when I add these together, the two y's are going to eliminate. They are going to disappear. So let's see what happens when we add them together. Keep the equals sign in the middle. Always keep that carrying down. X plus x is 2x. The reason I've added them is so that these two y's disappear, they eliminate each other, therefore there's no y's left. 5 plus 1 is 6. So x equals 3 in this case. If 2x is 6, x has to be 3. I've got one of my solutions. I then want to sub x equals 3 into one of the equations, 1 or 2. It doesn't matter which one it is, so I'll go for equation 1. Now equation 1 was x plus y equals 5, so 3 plus y equals 5, so y equals 2. Those are my two solutions for that one. X is 3 and y is 2. Next, now this one is set up again quite nicely, but what we'll notice here is both of these are negatives. Now, when we have both of our equations as negatives or both of them as positives, and this will be recapped in the next slide, what we want to do is, instead of add, well, these were different signs and we added, these are the same signs, that's opposite, so we're going to subtract. Can't quite fit the whole word in there, so subtract these two. The reason we are subtracting them is because, so we'll get rid of this bit at the top just now, I can show you why that is. So negative y subtract negative y is the same as negative y plus y. Those two negatives become a plus, which is 0. So subtracting these two will give you the 0 in place of y, so we'll eliminate the y. Now the reason we want to do this, the best way to remember it is different signs, add, same signs, subtract. And there's a little box in the next slide that helps you remember that, and in the notes. When we subtract these then, again we do the same as we do before with normal numbers. 4x take away 3x is x. The y's have been eliminated. 20 take away 17 is 3, and x equals 3. We don't need to do anything else here, of course, because we've got x on its own already. We do need to sub that x equals 3 into one of our equations. We can choose any one. I'll choose equation 1. Feel free to do equation 2 and convince yourself that it works the same way. Equation 1 is 4x take away y equals 20. 4 times 3 take away y equals 20. 4 times 3 is 12. Take away y equals 20. 12 take away what will give you 20? You can think of it that way. Or negative y is equal to 8. Change the signs. Y is negative 8. So solving equations, even though we're not using the substitution method, solving equations is still very, very important when we are doing simultaneous equations. Okay. Now on this next slide, this is in your notes as well, we have got a nice, lovely little recap of how to do these questions. Now this is going to help us a lot, so you can always come back to this, write this somewhere. If you've got your jotter there, write it in it. If you've got a piece of paper, write it down and have a look at this each time. Okay, so when we come to do the questions in the booklet, you're going to have to do that sort of thing as well. Okay, you're going to have to look at the signs and make sure that you are either adding properly or subtracting properly, whichever you're supposed to do. Now, the questions for this one are on page 2. Page 9, question 2. The only thing with these they're perfectly fine, in fact. Okay, so what to do is complete these. Now all of them are adding, because all of them have different signs. Okay, now we'll see later on that doesn't always have to be the middle term that we eliminate, so it's the y in all of these, but it doesn't have to be that term. Sometimes it can be the x, sometimes the x will be in the middle. It just depends on how our equations are set up, but we'll see that a little bit later on. Okay, so if you're watching on the video, pause this just now, or off you go. That'll be us ready to do question 2. Moving on slightly. So before, both of our equations were set up very nicely. We just had to add or subtract them once we had them in the form, okay, with one on top of the other. In this case now, we have got to consider our equations as not being so straightforward. So what we have to do with this one is to try and make one of our letters have the same number in front of it. Now in this case we've got 3f and 2g, we've got 1f and 1g. Either one of these letters works if you want to eliminate one of them. It doesn't matter which one you eliminate, but for now I am going to stick to the one in the middle. Okay, so we can multiply here the one equation, and we're going to go for the second equation. So this is equation 1, this is equation 2. I'm writing down my steps every time just to let you know what I'm doing. So I'm going to multiply equation 2 by 2. Now the reason I'm doing that is that will then make sure that my g's have the same number in front of them. So the top equation stays the same, 3f plus 2g equals negative 12. If I multiply equation 2 by 2, all of the equation must be multiplied by 2. So f times 2 is 2f, minus g times 2, that's minus 2g, and 1 times 2, of course, is 2. And now I can add these two equations together. Why? Because the g's have got the same number in front of them. Plus and a minus, different signs, means I need to add them together. When I add them together then, 3f plus 2f is 5f. Negative 12 plus 2 is negative 10. F then is negative 2. Okay, and once we have them in this form, this step here is the trickiest step generally, because once we have them in that form, it's the same process that we have to do. Scrolling down just a little bit, we are going to substitute f equals negative 2 into one of our equations. I'm going to choose equation 2. You can choose equation 1 if you like. Equation 2 was f minus g equals 1. If f is now minus 2, take away g equals 1. Minus 2, move it over to the other side, so minus g is positive 3, so g is negative 3. And that tells me that that's my two answers to them. So if I was to put f and g into both of those equations, I would create a number on the right hand side. Now for this equation here, I am going to try and eliminate a different thing. So in this case, this one, the top one's 1, the second one's 2. In this case, so I only need to multiply one of the equations. So if we think about the y's here, I would have to multiply both of them. There's no way I can times the 3 to make it into a 5, or times the 5 to make it into a 3. So what I can do though is if I look at the x's, there's 8x and 2x. So 2 is obviously the smaller one. That could be the one that's multiplied. I'm going to multiply equation 2. Apologies. There we go. multiply equation 2 by 4. And you'll see that is going to give me 8 x's in my second equation, which means those will be able to cancel out. So the first equation stays the same. It is 8x plus 5y equals 39. The second equation becomes 8x, so everything be multiplied by 4, plus 12y equals 60. I can draw a line under these. Now my aim here is to eliminate the x's, so I'm going to have to subtract, in this case, 8x take away another 8x will give me 0 here. 5y take away 12y, negative 7y. 39 take away 60 will give me a negative, and it will give me negative 21. Now normally these will all come out as whole numbers. It's not always going to be the case, I can't make that a rule for you, but generally it will happen, which means this one, as it's working, gives me y equals 3. When we come to do the second part, we now have to find x, so we substitute y equal to 3 into one of our other equations. So sub y equals 3 into one of the top equations. Let's see, I'll choose equation 2 because that's got smaller numbers. So the equation is 2x plus 3y equals 15. 2x plus 3 times 3 equals 15. And just the last couple of lines to finish this off. We have got 2x plus 9 equals 15. 2x is equal to 15 take away 9, so 6, and x equals 3. So y equals 3 and x equals 3 are our two answers for this one here. Next, in this case, as you can see for C and D, so I'm going to stop you just now. For C and D, you can see that I have got numbers here and numbers here, and the same for C, that are not going to be able to multiply up into one another. Now for these types of questions, I have got to instead multiply both of the equations. So equation 1 and equation 2, and I'm just going to write this out at the side what I'm multiplying them by. It's up to you what you multiply them by. We're trying to eliminate one of the letters, which means we need one of them to have the same number in front. Okay, in this case I am going to go for the B's, just because it's got the plus and the minus, and that means I need to add the equations together, and that generally is quite helpful to do that. Okay, so to make these two have the same number, I'm going to have to times this top one by 4 and times the bottom one by 5. When I do that, then I end up with 8a plus 20b equals 12. It's really easy just to forget one of these numbers, so do them process wise, do them one after the other and try and remember them all. Okay, as I said, it is kind of difficult sometimes though. So that's 15a, 20b, and 8a. Since we've got to eliminate the b's here, we've got 20 in front of both of them, so that will work to eliminate them. 20b, take away 20b, so we've got to add those two together, since they're different signs in front of the b's. When we add these two together, we end up with 23a equals 92. Now, you may not notice this straight away, but 23 will go into 92 4 times, so A is going to be 4. When we know that A has to be 4, we can then substitute A equals 4 into our next equation, or one of our first equations. So substitute A equals 4 into any equation we'll do. I'm going to choose equation 1. Equation 1 was 2A plus 5B equals 3. So 2 times 4 plus 5B equals 3. 8 plus 5B equals 3. Scroll down slightly. Couple lines left. 5B equals negative 5 if we take away the 8. So B is negative 1. And in this case, we have the two letters completed. A is 4 and B is negative 1. Next, we're going to label these two as 1 and 2 again. So equation 1, equation 2. And then let's see what we can times by. So again, I'm going to go for the numbers in the middle, just because that will end up meaning that I have to add numbers together, which is generally a lot easier than having to subtract them. So I'm going to times top by 3 and the top by 5. That will make my 2y's be 15. So top by 3 is 6x plus 15y equals negative 27. 25x minus 15y equals, we can do this at the side, 24 times 5, you can also do it in your head if you like, just use my calculator for it, 120. Now we can add these two together, since that we have got the y's being 15 and we've got different signs there as well. So 25, add the 6, gives us 31x minus 27 plus 120 gives us 93, and as we can see, things work out very nicely. X is 3. Okay, we're going to substitute x equals 3 into one of these. You can see this is very, very repetitive. It's just quite tricky each time, just to make sure you're doing the correct thing and to get all of the different steps correct. So equation 1 was 2x plus 5y equals negative 9. 2 times 3 plus 5y equals negative 9. Scroll down for the last couple of steps. 6 plus 5y equals negative 9. 5y, when we take away the 6, is negative 15, so y is negative 3. X is 3 and y is negative 3 for that last example there. On to the next page. Now on this page we have got, obviously as we can see, our equations that are up and above one another, okay, so that's what we like to see. However, they're not really in the same form. So with this one, we've not got a y over this side. With this one, we've not got a number over this side. So we do have to rearrange them at times. Not always, but at times we will have to rearrange these equations. So the first step for these equations is to rearrange them first, so we have them both in the same form. Now this first one, equation 1 here, I am going to leave as ax plus 3y equals 2. I am going to rearrange equation 2, and to do that I am going to move the minus 2y over to the left hand side. So it's 5x plus 2y and the 1 is still left over. Once we get to this stage, it's the same process as on the previous examples. We have got to make sure that one of our letters has the same number in front of it. I'm just going to choose the y's because they're smaller numbers. Times the top by 2, times the bottom by 3, and both y's will have a 6 in front of them. So, multiplying everything, we have got 16x plus 6y equals 4. On the bottom, we have got 15x plus 6y equals 3. Now in this case, I've got the y's that have the same letter, the same number in front of them, they have the same sign, so I need to subtract them this time. So 16 take away 15 gives me a nice singular x, 4 take away 3 gives me 1, and x equals 1. So this one has worked out quite nicely here as well. What we need to do next is to substitute x equals 1. You can see it's the same process over and over and over again. Substitute x equals 1. Any equation will do. I am going to choose equation 1. And we'll see what happens. So equation 1, let's write that down first before I scroll down. 8x plus 3y equals 2. And scroll down. Sub x equals 1 in, so 8 times 1 plus 3y equals 2. 8 plus 3y equals 2. 3y then equals negative 6 when we take away the 8, and y is negative 2 when we divide by the 3. So x equals 1 and y is negative 2 for this one. Next, get back up to the top. We've got to rearrange the top equation here. I'm going to leave the bottom one on its own and leave that as it is. For the top one, all I'm going to do is move the plus 8 over to the right hand side. So that becomes 4x plus 3y equals negative 8. So we have to take away the 8. And on the bottom, keep number 2 the same. 3x minus 5y equals 23. As we can see, none of these letters have the same number in front of them. I am going to try and eliminate the y's. So times top by 5 times the bottom by 3, and then both y's will have 15 in front of them. So we've got 20x plus 15y equals negative 40. We've then got 9x minus 15y equals 69. I need to add them this time. Why? Because the plus and the minus, they are different signs, and I'm trying to eliminate the y. 20 plus 9 is 29x, which equals, so we've got 29 here as well. If we do negative 40 plus 69, so x is 1. And we're going to again take the x equals to 1, substitute it into one of the equations. I am going to use sub x equals 1 into equation 2. Now, equation 2 was 3x minus 5y. Go. 3x minus 5y equals 23. Substitute that in, so 3 times 1 minus 5y equals 23. 3 minus 5y equals 23. Minus 5y equals 20 if we take away the 3. So y then is negative 4, dividing by that minus 5. Okay, and if we scroll down further, there are a whole lot of questions on this. Additionally, you could complete question 3 as well. But I will be posting individual questions to do. So I'll be posting, when I'm doing the live lessons, I'll be telling you to do this question, A, B and C, this question, first column and so on. Okay, so these questions are here for anyone catching up, not wanting to do it as much, not wanting to do the whole booklet. But I will be instructing you to do questions later on. So look at the Teams page mainly for your questions to do. This video is just really to get the notes. Okay. So that's us. Scroll down, done that example, done that one. Okay. Lastly, we have got to look at solving equations or simultaneous equations in real life context. Now these are the ones that you will see in most past papers. It requires you first to make the equations, and then secondly to solve them. So once we've created them, that's the only section that is new here. In this case, we have a builder that buys bags of cement and sand, so I'm going to use C to represent cement and S to represent sand. I'm not going to bother writing the words out every time. 4 bags of cement, 6 bags of sand cost £39. Okay, so 4 C's, 4 lots of C, and, so plus 6 S's, 6 lots of sands, costs equals 39. You will notice I've not put the pound sign in. Please do not do that. They will take marks off you in an assessment for doing that, unfortunately. Next equation, I'm going to write underneath 3 bags of cement, 3 C's, and 4 bags of sand plus 4 S's equals £28. So equals 28. Right, what I'm going to have to do, same sign, so I have to subtract at some point, but before I do that, I need to make sure that I have the same sign somewhere. The same number. So let's see, what could I multiply? Okay, what you might notice here is the 6 and the 4. We can multiply both of them by different numbers to make them up to 12, and that's what I'm going to do to try and keep my numbers a bit lower. So I'm going to times the top one by 2, that will make it 12, times the bottom one by 3, and that will make the S 12 as well. And what that will do is give me 8C plus 12S equals 78, and 9C plus 12S, the S's are the same, and 28 times 3, 84. I am going to have to subtract them to get rid of the 12, so it'll be 12 subtract 12 for the 2 S's in the middle. So 8 subtract 9 gives me negative C, and 78 subtract 84, so you can find the difference between them, put a negative, which means C is equal to 6. We're looking to find the cost of 1 bag of cement and 1 bag of sand, so I need to find out what these letters are individually. That's the first step. I'm not just looking for cement, I'm looking for sand as well. So we need to take then the C equals 6 and sub it into one of the equations. Doesn't matter which one, I am going to go for, what one's going to be easier? Let's go for the first one. Okay, so I should have labelled these two already, 1 and 2. Okay, I'll generally make them 1 on the top, 2 on the bottom. Right, equation 1 is 4C plus 6S equals 39. Can substitute that in there then. So 4C is 4 times 6 plus 6S equals 39. 4 times 6 is 24 plus 6S equals 39. Take away 24, 6S equals 39, so it's 1 and 5, 15. Yep. And if we do that, so 15 divided by the 6, we will get 2.5. So, the only thing left to do here is to finish off the question. All I'm going to do is say that cement is equal to £6, sand is equal to £2.50. Okay, finishing off the question there, especially since it's in context, it's best that we do that. Sometimes they'll take marks off for it, sometimes they won't. Generally, it's best just to make sure you have it in, especially with this question here being that that's 0.5, you need to make sure you know that that is £50. Okay, so next, got a similar question here. A red team scored 60 points with 7 correct answers and 2 incorrect answers. So I'll go for C is correct, and I is incorrect. And what we'll say here is the red team, we've got 7 corrects and 2 incorrects, and that gave them a total of 60. The blue team have got 8 corrects and 3 incorrects, which gave them a total of 65. Now this one's got quite large numbers, so you may be able to, this may be in a paper 2, okay? If the numbers are quite large, generally this will be in a paper 2, okay? If you use a calculator for it, I'm going to make the i's have the same number, so times this by 3, times this by 2, I will end up with 21c plus 6i equals 180, and bottom one will be 16c plus 6i equals 130. I need to subtract them because the numbers that are the same, the 6i's, have the same sign. I need to subtract them. 21 take away the 16, giving me 5c's. 180 take away 130, giving me 50. So c is equal to 10. This one may not be in a calculator paper, in fact, just because the numbers are relatively easy to work with. Okay, next step, of course, is to do a bit of substitution. So I'm going to sub c equals 10 into, which one? There's 1 and there's 2. Let's go for equation 1. Equation 1 is 7c plus 2i equals 60. And if we do that, so that's 7c, 7 times 10 is 70, plus 2i equals 60. Take away the 70, 2i gives us negative 10, so I is negative 5. Now if you think about that, that makes sense. C was the correct answer, so you would get 10 points for every correct answer. I was the incorrect, you would lose 5 for every incorrect answer. Okay, so you can see here, and we'll just finish that off by saying correct gets you 10 points and incorrect gets you minus 5. Okay, as I say, we can see that makes sense. So just try and make sure that you're thinking about the sense of it all as well. Okay. Now, these questions here are all about the worded questions, the ones you've got to make an equation and do that again. I'll pick some of these for the live lessons, but if you're working through them, that's where you'll find those questions. Lastly, we have got past paper questions. There's 1 and 2 here, just to finish off the notes, and then information on where to find them. Okay, so I'll do these ones relatively quickly, just to finish us off. We have got costumes for a school show, cloaks and dresses, so I'm going to use C and D. Now this is split up quite nicely for us. 2 cloaks, 2C, and 3D is 9.6. Okay, we would get 1 mark for that, which is very good. Next mark comes from doing the same with this next one. So 3C plus 4D equals 13.3. That gives you a 2nd mark. The good thing about this is you get marks all the way through. So that's 2 marks. Even if you mess up the rest of it, you still get 2 marks. Now, I've got these 2 equations here. It doesn't really matter which one I decide to use, which obviously letter I decide that I'm going to multiply. Okay, I'm going to take 2 equations, write them down. 2c plus 3d equals 9.6, and 3c plus 4d equals 13.3. Times the top one by 4 and times the bottom one by 3. If you choose to times the top by 3 and the bottom by 2, that will give you your c's with the same number. All I'm doing here is making my d's have the same number. 8c plus 12d equals, and we'll do 9.6 times the 4, 38.4. And next we've got 9C plus 12D equals 39.9. Okay, we are going to have to subtract them, giving us negative C, and that will give us a negative over here. I believe it's 1.5. I'm just going to double check that. Yeah, 1.5. Since they're both negatives, then we can make them positive, so C is 1.5. Now we can put that into our equation. So we're going to sub C equals 1.5 into one of these equations here, either 1 or 2. Let's see what we'll use. I'll use 1 because that'll give me a whole number. So it's 2C's plus DD equals 9.6. That's going to give us then 2 times C is going to be 3 plus DD equals 9.6. Take away the 3 from 9.6, so 3D is 6.6 and D then is 2.2. We need to go back and answer the questions. We're looking for how much material is needed for one cloak and one dress. So C was the cloak, and that was 1.5, and the dress was D, 2.2. And that's us answered the questions. Okay, with these context questions, just make sure you do answer that at the very end there. Past paper question 2, we are given, so I spoke about this at the start, we're given these two graphically, but we have to use them algebraically. We have to solve them algebraically to then find the answer. We can't just pick off the point. So there is equation 1 and equation 2. I'm going to start by timesing the top one by 3. And that will give me the same number for the y's. Now if I do that, times the top one by 3, I get 9x minus 3y equals 6. On the bottom, x plus 3y equals 19. So that one's staying the same. I'm not changing that at all. I need to add them together because my numbers that are the same have got different symbols. 1 plus and 1 minus. Add them, 10x is equal to, what's that, 19 plus 6 will give us 25. So x is 2.5. Now we can do this even without a calculator because we can substitute everything in. So if we use x equals 2.5, sub into equation 2 we'll go for. So that is x plus dy equals 19. So we'll take this and we'll put 2.5 in here. That's why I've chosen this one, because I didn't have to times it. Make that 19. Take away the 2.5 from the 19, so 3y is equal to 16.5. And when we divide that by 3, we get 5.5. Okay, this here is a coordinate. So to finish that off, we need to say that P is equal to x was 2.5 and y is 5.5. So make that into a coordinate for that last bit. Now, the end question here is looking at the past paper questions and the ones at the very end of the booklet. And that takes us on to the last bit. So you can fill in notes, you'll get them on the Teams page in the file section. You can fill them in, and if you can, just make sure you're going through the live lessons as much as possible, just using this video